Casey, welcome to the Built for Trust podcast. How you doing?
I'm doing great, Nick. Thanks for having me today.
I'm so psyched, to have you and to talk about both, you and your career journey, but then really, around GrokStream, as well. So, good company that we kind of discovered, through the, AI networking summit, So let's start, a little bit about introducing you to everyone and making sure everyone knows like who you are, right? So why don't we take a little bit of time, you kind of talking through kind of your career journey. So and it'd be good. I think you were with Phil T. Was it over at Moogsoft before you did GrokStream or before that?
No, the first company that I started was a company called Generation E Consulting, and we were one of Phil's largest reseller / SI partners.
Okay.
That's how we met.
Okay, great.
Yeah.
Okay, very good. All right, sorry, I didn't have that story totally accurate. So, but so which also is always a reminder for me not to try to like tell anybody's career journey and for let them to tell their story. So go for it.
Okay. Yeah. No worries. Yeah. I'll kind of back up a little bit before the career because I think it'll give our audience some insights into why the journey took the route that it did. But I grew up in a small rural farming community in Texas. Went to college at University of Chicago and studied mathematics, and that's where I kind of got the bug for, trying to solve deep problems, really finding beauty in complexity, and took out of that kind of quant background. Most of my compatriots that weren't going into academia were interviewing with investment banks. That was the big thing back in the day. Of course, I got some offers with iBanks, but took a job at Deloitte Consulting doing IT strategy. And the first phase of my career was at Deloitte, and I just happened to land in a practice that was doing some basically large, what they called enterprise systems management design and deployment projects in Silicon Valley with the dot-coms. So I was, right in the thick of things when the dot-com boom was in its full stride. And my job was to work, of course, on a large team, but to figure out how to help these companies as their networks were expanding rapidly. The adoption of technology was really taking off in the world. How they're going to manage the technology infrastructure required to deliver these new services, and just fell in love with that. I mean, the complexity involved, the challenges, it kind of hit the chords of the types of problems I like to solve. And I started my first company after doing that in Silicon Valley for 2 years, Generation E Consulting, and that's where I met Phil and his team at Micromuse, because our strategy, in starting that company was so I knew the problem space that we loved, and the way we attacked the problem was to find the most innovative technology companies, software companies that were taking bits of the problem and put them together and come to the market with a reference architecture to solve it with large enterprises, service providers, kind of the most complex networks available at the time. And so that went really well. Grew that team. We had 150 engineers doing projects all over the world. But phase 2 of my career was I really found that that what was lacking was automation. Even though my goal or our goal was to let engineers do what engineers do best, and that's solve new problems and not and free up engineers from all of the service assurance and support work. What we found was even if we built the best reference architecture, most modern technology stack, we still saw way too many engineers doing support work. So we started a software company called Resolve Systems that really was, the thesis behind it was to institutionalize automation and therefore free up engineers to do engineering work. That went well. We sold that company to Insight Venture Partners and started GrokStream. And the thesis behind GrokStream is and still is to rewrite the DNA of the whole stack. using AI.
Mm, yeah.
And that's kind of the career journey.
Yeah, that's actually a great journey. So, can I put like a little time frame on that? So, like at Deloitte, like what time frame was that?
Yeah, that was from 98 to early 2000.
Yeah,
And
great time frame. Yeah, so like you know, yeah, so that was like kind of just at the beginning of the internet. Like Mosaic had come out. It's like, yeah, so great. So you're kind of a whole internet wave. A lot of companies needed a lot of help at that time to kind of figure how do we now move off of like IBM, or not move off of IBM mainframes and SNA, but how do we support all this client server computing and PCs? Yep. So
that's
it's
right.
all right. That's great. Yeah. And then the consulting company that you started. Um,
Yeah. So,
so
so that was in the early 2000s. Towards the end of 2007, I realized that I really started getting interested in the automation problem. So we
yeah,
launched Resolve towards the end of 2008 timeframe, um, but uh, exited the consulting firm shortly after that and focused on Resolve for about 5 years. And
yeah,
kind of felt like we had solved that problem, and I got the itch to go deeper and started thinking
yeah,
about AI, and that's when we launched Grok about eight years ago.
yeah. Great. Yeah, very very good. Actually, I love that trajectory. Because like when you're like, I'm sure you learned so much at Deloitte. And also like in your own consulting company, is that you get to just see so many different problems, and also you get to see which ones are repeating all the time. But I think that's probably the greatest value there. As well. And then that kind of like you've already done kind of the operational research to kind of figure out what's missing in the marketplace and what's needed. So yeah, great journey to kind of set you up, for where you are now. And that all, what's really, I think, important about that for GrokStream is that you spent so far a large chunk of your career in this space, so you haven't kind of like got up, it went into storage or went into like compute, or went into applications. You've really been in infrastructure this whole time, and you've built up a very kind of large library of skills and expertise and people, contacts in this space. So
Yeah.
okay, great. So, all right. So you've been at Grok for a while, now. So, and the way that I view GrokStream is it's kind of like um, a next generation platform of AI ops. So it's how do we now kind of the infrastructure and the infrastructure components deliver a huge amount of data to operations teams. Unfortunately, and it's for I would say selfish reasons, that the industry has not been able to consolidate on a common format. Transports, yeah, whether those are particular APIs or ways to kind of stream that data, but the schemas are all different. So the question is that, and I think where Grok Stream provides a lot of value is that you can ingest data from a lot of different formats. You guys you do data collection, you do canonicalization, of that data, you do correlation, and obviously analytics. Anyway, that's what when I think of GrokStream, that's what I think of. And so, is that accurate or am I off?
Yeah, no, you're spot on. I think what sets us apart though is how we approached it from the beginning, Nick. So because we've spent so many years in the guts of the problem, when we started trying to rethink it, the idea was the complexity of the data is a problem that's better served or better solved using AI at the outset. So whereas trying to sort of enrich data and build common data formats and schemas in order to drive intelligence, we said let's start with the idea that the the first phase of intelligence, much like the for human beings, sensory data is very complex. We have multiple sense organs with lots of different formats and implicit meanings. but we have a part of the brain that's uniquely designed to process, canonicalize, and down select that sensory data and pass it up to the next layer of intelligence. So we started from day one with the idea that we don't want to build any kind of rule sets on the ingest to force a kind of mode of thinking, but instead we start with pre-processing as a layer of intelligence and pass it up to the next layer of intelligence. We build kind of on the problem sequentially until we've solved the sort of, we built as much machine intelligence into the entire space as we possibly can.
Yeah. Okay, that's great. So like, that's it's because the other way to do that is that you create all these different kind of modules for particular scenarios,
Yeah.
so you can ingest that data, and then in those kind of modules, then do all of that processing, try to canonicalize them. You have to put a lot of rules in place. There's a lot of kind of toil and overhead, kind of associated with that. So yeah, so that was an ingenious part of the architecture, early on. But I think I'm getting a little bit ahead of where I wanted to go to. Let's first, before we kind of really dive into the architecture and the use cases and then the outcomes, is spend a little bit of time talking about current state of network operations. Because this is really all about automating as much as you can network operations, right? I think that's,
Yep.
But Grok can scale beyond network operations. The model should be able to transcend into like security ops or SecOps, SysOps, so, it's, the networking space is a big space, but I think what you've built with Grok is um, kind of a kind of a full stack, AI operational system.
Yeah.
Um, so let's talk about current state, of networks,
Yeah.
operational teams, and kind of like, what you're seeing, and then what was the key thing that said, wow, this really needs to be automated.
Yeah. I mean, I think if I were to describe what I think the current state of thinking is, it's really in transition from a, sort of use case centric approach like you described, where we try to solve problems with the help of AI machine learning on a case by case basis, not on a domain, not the top level domains like service assurance or security operations, but for specific use cases. And I think that was kind of a POC for the industry, and I think there's folks have seen enough success with that that now they're thinking bigger and realizing that the entire kind of legacy way of solving these problems needs to be redesigned. And so I think right now, I think the industry is in a transition mode with kind of initial validation that AI is really important and that it can solve problems. And now people are starting to put their design thinking hats on and think, how do we fundamentally change the way we solve these problems using AI as the backbone? And I see it and I think your point is really accurate. We started, our first customers at Grok were, really large legacy telco service providers and very large MSPs where they had to do something. It was an imperative that, because the kind of pace of adoption and complexity on the consumer side
Hmm.
was outpacing their ability to manage the infrastructure. And so there was a large impetus. So we
Hmm.
kind of hardened our design and architecture in that environment. And now that we have that sort of overall AI strategy and architecture, we've deployed at enterprises for application assurance, completely outside the networking domain. We didn't have to go and become experts in SAP or any other app domain. We plugged our architecture, consumed the operational data related to the apps, which included networks, of course, and the model just worked. It took it as sensory data on the input, and on the output, we drive efficiency across the application assurance pathways. So we, create one ticket when there's for every problem, and every single ticket has all of the operational data relevant to that problem. We've eliminated the noise and made it really easy to tie automation to the problem, because we've isolated each problem as they evolve kind of out of the application stack.
Wow, awesome. Yeah, yeah, that's right. That's yeah. So it's interesting. So kind of a transition, and I see this too. It's like even within the community, there's been a lot of focus around kind of automation for some period of time in the operational, ranks, and so everyone is on somewhere, on their own maturity map, or their own journey on there, but they're all moving, in the right space. The only thing that my own observation is that a lot of the kind of earlier automation was around toil mitigation, and I think that's useful. But I think like if you're still really thinking about toil mitigation, you're going to be really far behind, because like tools like GrokStream and others, they're you're not only just getting the toil mitigation, but you're getting the automation, and you're getting a whole set of applications on top of it, as well. So you're missing a much bigger play if you're just kind of focusing on that kind of small aspect of automation. But so anyway, so going from kind of reactive to more proactive is kind of probably a good way to kind of frame it,
Yeah.
as well. So then
Yeah.
let's think about infrastructure data, um, and like in how you're gathering that data. It's obviously there's telemetry, and there are APIs for particular companies. There's even SNMP and NetFlow and all of those different kinds of outputs. So, what are you focusing in on? Like, what are you ingesting when you're in a in a large organization?
Yeah, it's a good question. So we treat all operational data as a relevant data source for our machine intelligence. And what do I mean by that? So we consume alert data, obviously. Those are the simplest actionable bits of data that flow off the operation stack. We
Yeah.
consume metric data. We consume log data, really all forms of telemetry data. But we
Yeah.
pre-process that telemetry data depending on the data type. So for log data, we have a semantic clustering algorithm that pre-processes the log data and extracts what's relevant, what's different, what's
Hmm.
important, and we pass that upstream. For metric data, or time series data, we pass it through an anomaly detection layer to pre-process it, pass just the anomalies up to the next layer in our architecture, and so on and so forth. So the first kind of beyond ingestion, the first layer of the architecture is our clustering layer. And the job of the clustering layer is to tie all of that operational data that's been pre-processed together, such that every what we call detection or group of operational data is related to the same underlying cause. So we partition the operational data based on causation, and then ask the question to the next layer: does it matter? Is it important? And if it is important and it does matter, requires action, what is it, and what kind of action should be taken? So we approach it systematically, and we use the best kind of algorithm for the particular layer of the problem, and then pass the output of that algorithm up to the next layer of the problem.
I see. Okay, great. So, all right, very good. So, there's a lot of kind of pre-processing that's going along, and then kind of built in both exceptions and escalations, to that both log metric and alarm data. Okay. Is there for compliance reasons? Many highly regulated entities, corporations need to store that data. So are you just getting, you're not getting the single source, of course. There's a fork, I would think. And, so you're getting a copy of that data, and the other kind of raw data is being stored probably somewhere maybe in a data lake or S3 buckets or what have you. Correct?
Yeah, I mean, so it just depends on the organization. We have customers that, because we do have, um, we keep a large data lake because it's our training bed, and we train in line, so our models don't need to kind of tap the lake every time we get new information and need to update the models depending on which layer we're talking about. But we do keep a
Mm.
copy because we need to. There are times when, for disaster recovery or for parameter tuning and optimization, we do have a large data lake, and there are customers of ours that have moved from, as they realized that, they said, why are we keeping a copy of all of the data when we can just tap the data lake that sits next to Grok for training purposes for analytics? And so we can kind of consume that historical data for analytics purposes. We have it for a different reason. Grok cares about the intelligence, right? The machine intelligence that we offer to our customers. But the data lake has a twofold value. It can be used for training models, but it can also be used for analytics.
Yeah. Okay. All right. Very good. Important point for all of the regulated entities that are kind of plugging in and listening. Okay. Good. So we talked about how you kind of gather data. We talked about the schemas. We talked about the kinds of data that you're looking at. We also talked about a little bit about some of the processing of that data. So and also what happens during particular events, whether something has to be escalated up. So now, all right, so great. You have all this data. You've got this canonicalized vision, or you have this canonicalized data. You, I'm kind of assuming, correct me if I'm wrong here, is that you can kind of look at, I would think it depends upon the environment, but you know what the application is, and everything that is in that application's dependency map. All right, so it's the application, it's the server, it's like the kind of the NICs on it, it's like the top of rack switches, the core switches, it's like, and all the way through. So you can actually see, how an application is performing and what a user's experience of that is. And maybe I'm sure that there are metrics or policies that the developers, have put in place, and they want to, okay, when we're out of that range, raise red flags, or there's a whole bunch of analytics now that could be done around that, whether that's predictive analytics, capacity, analysis, performance analysis, and so forth. So this, I think, becomes part of the really interesting part, of the Grok solution. It's kind of what are the applications, and how are kind of operation teams and also maybe even developer teams are kind of utilizing the platform.
Yeah, that's a great kind of setup. So one thing to answer that and just clarify for your listeners, the representation that you mentioned, sort of how things are connected and how they relate to each other from a causal standpoint, is something that kind of sets us apart. We don't construct a topological view explicitly. Grok learns the relationship amongst all the entities on the network and apps, and everything that is required to deliver a service, a technology service to a user, by observing behavior on the network. So it builds a representational memory that can be viewed as a graphical model, but is not a graphical model. It's a collection
Mm-hmm.
of similarity matrices at different uh, uh, we call it semantically folded temporal clustering. And the representational memory will tell you how things are related. You can view it, you can extract the information and view it graphically, but it's not a graphical model that's allowing Grok to make decisions any more than we have. Human beings can explicitly say how every object that we've ever observed is connected to every other object, right? It's not part of the semantic extrinsic knowledge that we tap into when we talk about things, but we make decisions every day automatically based on that knowledge, based on observational data. And that's what Grok
Mm.
does. It builds that representation. Um,
Okay.
and the use cases are I'll just mention one. So we had one customer that said, okay, this is, years ago. Well, we have all this information. You don't just know what the incident pattern, you don't just know when incidents occur. You know everything about the incidents. You know all of the operational data that fed into a decision that something bad, is happening, and everything around that occurrence, right? So why can't we predict in advance when things are going to break? And so we worked on that problem with the customer and built a hidden Markov model that doesn't that you know to do it otherwise, you would have to know for every single possible problem that could happen, you would have to know the root cause explicitly and try to predict that root cause. Instead, we treated the incident patterns discretely and built a hidden Markov model that will give our customers a 24 to 48 hour prediction window, and for a large, not every incident, but a large portion of the incidents we can see in advance of the incident happening.
Yeah, well, that's huge, especially for kind of a revenue facing or revenue generating kind of application. If the application was like eBay, that's
Yeah.
like, yeah, that's pretty huge, to kind of like know, 24, 48 hours. Okay. Hey, this part of the dependency map is, potentially causal, and either degraded performance or downtime. That's huge. So, are there others that's big enough? That's a big one, right there, But what about like capacity planning? So one thing, for example, as as large corporations, are everybody's on their journey also to kind of AIify their enterprise. So more applications become kind of AI enabled. Some large corporations are building their own AI clusters. But we know that kind of AI is, will be an ingredient in all applications that we're consuming. The thing we don't know though is what effect, if any, that those applications will have on infrastructure, right? Will data gravity move? Will traffic patterns shift? Will, latency requirements, change? What's the security posture and profile, to support that particular, application? So you can kind of keep on going on and on with that. And I think we used to build and do capacity planning based upon peak traffic, right? We would kind of look at where the peak traffic was, and then we would use that as a kind of high point on, okay, that's how much capacity we need, and we would build out the infrastructure to that, and we would tweak it, really from there. Where I'm not sure if that's, that model is going to really help us, anymore. So can GrokStream, help in the kind of capacity planning and kind of absorbing, with all of the data that's ingesting, seeing if there are kind of shifts in traffic that are happening and all those metrics I just mentioned, are those metrics kind of changing? And if they are, okay, then, either red flag it or use that to feed into a capacity planning application.
Yeah. Yeah, I think you're right that building a regression model across every possible variable that drives that is affecting consumption patterns, traffic patterns, and trying to do that, via regression is not a viable solution. What Grok can do is, because Grok understands how the behavior of the network is evolving over time, we have what we call a problem management queue, which essentially surfaces the reoccurring incident patterns. So reoccurring patterns that are observed over time. And as that frequency increases, that gives us an indication if there's an element of that problem or a common element across many reoccurring patterns that are driving the issues. And the first question you ask is it a capacity issue? I can give you a list of top 10 likely elements in the network that are at the root of a vast majority of the incident patterns and determine is it a capacity issue? Is it a iOS version issue? There's something at the core that's causing that. So we can pick out and indicate where we might have capacity issues on the network via directly out of the machine intelligence.
Yeah. Yeah, that's excellent. That's like that's a great tool to help in the whole capacity planning and scaling, of the infrastructure to support applications as the applications are changing, right now in a pretty significant way. So maybe one or two other kind of questions, Casey. One is around there's really two. One is staffing. So network engineers, security engineers. There's a shortage of them. We don't have a large pipeline also of new people coming into the industry. There's also a lot of the older folks, are basically aging out, of the industry, as well. So for those who have deployed, GrokStream, what have you been able to observe from an operational staffing point of view? So usually no one will reduce their staff because they can do other things. But maybe is it that the amount of complexity inflation can increase without adding staff? Maybe is it that lower level kind of level one engineers with these kinds of tools, they're able to operate at a higher level, than they were. So, I guess like, what's your observation so far? You've been at this for a while now, so I'm sure you've kind of seen how Grok has the outcome and the input on the operational staff.
Yeah. Yeah. I mean, our central goal is to take if you take a talented engineer, consider their time as a limited resource. We want to minimize the amount of that time that's spent doing repetitive or low level tasks. So our entire thesis is our intention is to automate that. And we do that in a number of ways. Number one is we take out all of the duplicated effort. So where some customers might have generated for a fiber cut or a major incident, 10 to 20 discrete tickets and have people working in parallel on those problems, we collapse that down. So what we've seen in our customers is that about 70% of the work that's done in a L1 and L2 function has happened. If you look at what they do in a given day, they've done that same job at that exact same thing at least 3 times in the last 3 months. And we can observe that in Grok. And if kind of stack rank all of that work and start picking the top items off and automating those items, the most repetitive, we begin to free up more and more of their time. That's number one. Number two is we reduce the inefficiency caused by noise. And noise can happen in a number of different ways. It can happen at the kind of the alarming and observability layer, where we just get multiple alerts for the same problems, multiple alerts, multiple log messages, multiple flashing lights when a metric starts misbehaving on a screen, right? We get lots of duplicate information, and we collapse that down and do a single consumable bit of information that tells you this is what the problem is, this is what the impact is going to be, and here's the priority of that with respect to everything else that's happening right now. So we just reduce the amount of inefficiencies in all of that work and just free up their time to do higher value engineering work.
Yeah, that's great. That's what I would think. It's like you're really kind of inefficient, or it's an efficiency play. And I would think also it kind of the other outcomes of this are going to be increased uptime, better reliability, and so forth, since you're able to really kind of like look at metrics and take preactive action against it. But I think for for the staff, it's like we've heard from lots of folks, within the community, especially like Gene's son, shared with us, earlier in the year, is that when we were talking about AI and staffing, is like, people are worried about their jobs, but it's really his comment though is that AI is not going to take your job. It's people with AI skills are going to take your job. Having GrokStream is like having AI tools and AI experience. So you'll be able to
Yeah.
kind of be more productive and just deliver kind of a greater value to the business and the operation that you're currently participating in. So
Yeah.
okay, great. So I wanted to hit that one. Did you want to add anything to that,
No,
Casey?
yeah. I mean, it's going to free up more of your time to do engineering work, whether that's kind of AI related on the operations side, or if that's just evolving the service that you guys that the customer delivers to their customers.
Yeah, yeah. I'll tell you, it's been really stark. Like, we did a survey in the April timeframe about asking the community, oh, how much are they putting AI into their network and security infrastructure, and um, and then we asked about okay, what are you seeing benefits, and then we asked the same question in September, leading up to October. And the difference is just stark. It's like we kind of went from folks who were kind of doing, just initial deployments or just, in a study to like actually into a deployment that shifted up, from in the last 6 months. And then also the return too. So like they're actually seeing an improvement in their operations. And so we were able to measure that within 6 months. And I think the other key thing was that in the beginning of 2024, even though like we were clearly high on the ChatGPT hype cycle, which kind of permeated throughout the industry around AI, we kind of it was still early. Is that okay? Is this really going to be a something that's going to have a large impact onto you know business value creation? Or is it a kind of an efficiency kind of technology? And we saw that shift big, within 6 months, where everyone bought into, or really, well, they basically, I wouldn't say everyone, but it's like, a very large percentage of the community, kind of bought into, yeah, no, this is going to have such tremendous impact, on our operations and our ability to kind of deliver business value. So I think this kind of discussion feeds right into that. It's that you've already kind of built. You did first principle thinking a while ago with GrokStream, and you added AI and you applied it to places where it could add a lot of value, especially like in the data collection and the canonicalization, of that data, and then also the analytics, of that data, as well. So the return, should be pretty high with those customers who are actually using it.
Yeah, definitely. I mean, we've seen it. I mean, we believed it at the outset and spent a number of years really trying to solve this problem from first principles in the lab. And after 3-4 years in the lab, we started testing one kind of layer of the problem at a time with customers. And now I feel like we've solved a problem domain, and I think that's what we're going to see more of. We're going to see AI go from sort of use case centric. We want to see if we can deliver some value for a specific use case to design thinking. How do we use AI to solve a problem domain? And
Hmm.
which may contain a collection of use cases.
Yeah. Yeah. Very good. Awesome. Okay. So it's towards the end of the year. Time for everyone to do predictions. You got a prediction for 2025?
Yeah, I think I have two. One is
Huh. Nice.
we're out of the transition. Like we're going to see the close of the transition phase of thinking about AI in terms of use cases to thinking about AI in terms of problem domains and AI agents for each problem domain. And an
Hmm.
agent won't consist of a single algorithm or a single technique. An LLM won't solve an entire problem domain, but it'll be part of many solutions to individual problem domains, whether it's service assurance like us, service assurance and operations, or Salesforce automation, or whatever that problem domain is. We'll have AI agents that really make transformative changes across those domains. And then I think we're going to see a shift in how we think, because there's been so much hype around LLMs, Nick. I think we're going to see a shift. Like, I think folks have sufficiently kind of peaked on the hype cycle, see the power of LLMs, and they're going to start seeing kind of concentrating that kind of energy on using LLMs as a human machine interface in the agent context. So we'll have agents for problem domains, and our LLMs will be what sort of allows humans to act like superhumans in that domain. So, they'll be the fulcrum for augmented human achievement within a given problem domain. So LLMs are going to continue to get kind of excitement, but they'll be more focused, and they'll be the focus will be on how do I use the LLM as a human to machine interface for the machine intelligence across a problem domain.
That's interesting. You're thinking kind of federated AI agents then, to kind of attack a problem within a domain.
Yeah, multimodal AI is, I think, what's going to be the next kind of exciting thing, because that's what you need to solve a complex problem that models complex behaviors. It's not one algorithm. It's not one strategy. It's a multimodal strategy where you connect different algorithms across the domain to solve a broad set of use cases in that domain.
Yeah. I love this thinking, and this is not a prediction for 2025, because I think it won't happen in 2025, but it'd be great if we start to it becomes part of kind of an industry discussion. And that is just like what you're doing kind of in service management. If you think of service management as a system of record, and then you can look at like Salesforce automation, you could look at, financial reporting, you could look at manufacturing, it's like all of the various different system of record systems within a corporation. And they too need to be going through this transition from more of a reactory or deterministic, kind of software stack into much more predictive, so that we can actually see a corporation, it's executives and board can actually then have tools to do kind of predictive analytics. Like if we change the price on this, what might happen? If we increase it, if we open up these new stores in this particular geography, if we concentrate our distribution centers, it's like all of these multivariable problems, which were always kind of done with analysis, but really when it comes down to it, it's like, hope and a prayer, it's all going to work out. Is that, can we get some real, predictive analytics, to help in making a bunch of, business problems, that really kind of moves corporations into a very different, state. It's a much more predictive organization. You can respond better to customers, to competitors, real competitive differentiation. So, it's more of a hope for me for 2025 that we kind of start to think about that. What's really good about what we've been talking about, Casey, is that, all right, this is already happening, in kind of service management. It's not too different to kind of move that into these other domains, within an organization. So.
I agree with you, Nick. I mean, you to solve the problem domain.
Casey, that's all I had.
Okay.
Okay, thanks. No, go ahead. You can finish. I'm sorry, I cut you off. Go ahead, finish.
No, I was just agreeing with you. I think definitely there are going to be commonalities, and it's just going to accelerate from here.
Yeah, awesome, great. Well, Casey, thanks so much for the time. It was a pleasure chatting with you, and congrats, on Grok and GrokStream. Thanks for being a part of the community as well, and happy holidays.
Thanks, Nick. Same to you. It was a pleasure.